GeopByte.
Welcome to GeopByte. Hi students, in this video we are going to start the new chapter, that is chapter number 3, Understanding Quadrilaterals, and we are also going to discuss the introduction part to the Understanding Quadrilaterals. In your previous classes, you have already learned about plane surfaces and plane curves. For example, a paper. A paper is an example of plane surface. Now, let us draw some dots and join these dots with the free hand. Now, this is a plane curve. So, a paper is an example of plane surface and a curve joining these dots is a plane curve. Now, let us know about a polygon. What is a polygon? A simple closed curve in which it is only made up of only line segments. That is, a simple closed curve made up of only line segments is called a polygon. For example, these are the curves which are polygons. So you need to know that only it is made up of line segments. And next, these type of curves are not polygons. So curves which are not polygons. Because a polygon means a simple closed curve made up of only line segments. Here these two are not closed and here we have three closed surfaces. So it is not a polygon. So curves which are polygons are these. So for example, rectangle, triangle, square, a pentagon are the examples of regular polygons. Now let us see classification of polygons. Here we have a table consisting of 3 columns. In the first column we have number of sides or vertices. In the second column we have classification, and in the third column we have sample figure. We know that we require minimum 3 sides to construct a polygon. So that's why we have started with the number 3. So number of sides or vertices is 3. So a polygon which is having 3 sides or 3 vertices is known as triangle. So triangle has 3 sides and vertices. It is drawn like this. So the figures which are having 3 sides, 1, 2, 3, 1, 2, 3, 1, 2, 3, and it has also 3 vertices, 1, 2 and 3, 1, 2, 3, 1, 2, 3. So these type of figures are called as triangles. Next, number of sides or vertices equal to 4. Quadrilateral. The figures or the polygons which are having 4 sides or vertices is known as quadrilateral. So quadrilateral is made up of 4 line segments. It may be of equal lengths or different lengths. So quadrilateral is made up of 4 lines or 4 sides. 1, 2, 3, 4. In this 1, 2, 3, 4. Here also 1, 2, 3, 4. And these 3 figures having all 4 vertices. So these type of figures are called as quadrilateral. Next, 5. The polygons which are having 5 sides or vertices is called as pentagon. Let us draw a sample figure. So this is a sample figure of pentagon. Here it has 5 sides, 1, 2, 3, 4, 5, and it is having 4 vertices, 5 vertices, 1, 2, 3, 4, 5. So this is a sample figure of pentagon where it is having 5 sides and 5 vertices. Next, number of sides or vertices equal to 6. So the polygon having 6 vertices or 6 sides is called as hexagon. The sample figure is here we can see that this is a figure consisting of 6 sides and vertices. So 1, 2, 3, 4, 5, 6. 6 sides and 6 vertices. For this figure also we have 6 vertices and 6 sides. So these type of figures are known as hexagon where it is having 6 sides and vertices. Now let us see for the number 7. Number of sides or vertices equal to 7. So a polygon which is consisting of 7 sides or vertices is known as heptagon. The sample figure can be so this is a sample figure of heptagon. Here it is having 1, 2, 3, 4, 5, 6, 7. 7 sides and also 1, 2, 3, 4, 5, 6, 7. 7 vertices. So this figure or a polygon is having 7 sides and 7 vertices. So it is called as heptagon. Now in the place of number of sides we have 8. So a polygon which is made of 8 sides or vertices is known as octagon. The sample figure will be so in this figure we have 8 sides and vertices. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides and 1, 2, 3, 4, 5, 6, 7, 8. So in this figure we have 8 sides and 8 vertices, so it is called as octagon. Now, in the place of number of sides, we have 9. So, a polygon which is made up of 9 sides or 9 vertices is known as nonagon. The sample figure can be here. In this figure we have 9 sides and 9 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides and 1, 2, 3, 4, 5, 6, 7, 8, 9. So this figure is consisting 9 sides and 9 vertices. Therefore, it is known as nonagon. Now next, let us see for 10. So the number of sides which are having 10 is known as decagon. A polygon which is made of 10 sides or vertices is known as decagon, and it can be shown as here. In this figure we have 10 sides and 10 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 sides and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 vertices. So the sample figure is consisting of 10 vertices and 10 sides. Therefore it is known as decagon. And so on up to the n number of sides or vertices. N number of sides or vertices. It is classified as n-gon, and the sample figure can be drawn with the help of n number of sides, that is infinity number of sides. Now let us see the concept of diagonals. First of all, what is a diagonal? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Let us write the definition. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. So, a diagonal is a line segment connecting two non-consecutive vertices of a polygon. Consecutive means side by side. Non-consecutive means not side by side. For example, let us draw some figures. Here we have drawn three figures, and let us draw diagonals for it. Here A, B, C and D. Here consecutive means side by side. So consecutive of A is A, D and B, and the consecutive of B will be A and C, because these are side by side vertices. Non-consecutive means, so the non-consecutive vertex of A will be C, because it is not side by side, it is alternate side. So AC will be a diagonal and D and B are not side by side. So DB will be another diagonal. So AC and DB are the two diagonals for this figure. And let us draw diagonals for this figure. 1, 2, 3, 4 and 5. This figure is having 5 diagonals. A, B, C, D, E. So DB and DA are the two diagonals. Also EC and EB are the two diagonals, and AC, BE are also the diagonals. So completely there are 5 diagonals in this figure. Now let us draw diagonals for this. P, Q, R, S. So QS is a diagonal. Here QS is an interior diagonal. We can draw also an exterior diagonal, that is PR. Here PR is an exterior diagonal. Therefore, for some of the figures we have interior diagonals, and for some of the figures we have both interior and exterior diagonals, and there are also some figures which are having only interior diagonals and only having exterior diagonals. Now let us know about convex and concave polygons. First of all, let us write the definition. Convex polygon. A polygon which is not having diagonals outside the polygon. So concave polygon, a polygon which is not having diagonals outside the polygon. For example, this is a polygon. We have the diagonals only inside the polygon but not outside the polygon. So these are the figures which are having only diagonals inside the polygon but not outside the polygon. So these type of polygons are known as convex polygons. Now let us write the definition of concave polygons. Concave polygon. A polygon which is having at least one diagonal outside the polygon. So concave polygon, a polygon which is having at least one diagonal outside the polygon. For example, this is a polygon. Here we can draw diagonal outside the polygon. So this figure is known as concave polygon because it is having one diagonal outside the polygon. And also for this type of figure, we have one diagonal inside the polygon and we are also having diagonal outside the polygon. So this type of figures are known as concave polygons which are having at least one diagonal outside the polygon. Now let us see the concept of regular and irregular polygons. First of all, let us write the definition of regular polygon. Regular polygon. A polygon which is having equal sides and equal lengths, equal angles. So regular polygon means a polygon which is having equal sides and equal angles. For example, let us take a square. We know that in a square all sides are equal and the angles are also equal. A, B, C, D. Here AB is equal to BC, BC equal to CD, CD equal to AD and DA is equal to AB. So we say that all sides are equal and all angles are also equal. So a square is an example of regular polygon and an equilateral triangle. PQR. So QR is equal to RP, RP equal to PQ and PQ equal to QR. So all these three sides are equal for an equilateral triangle and the angles of an equilateral triangle are also equal. So angle P equal to angle Q, angle Q equal to angle R equal to angle P. So equilateral triangle is also an example of regular polygon. In these two examples, we see that all sides are equal and all angles are also equal in the regular polygons. Now, let us see for irregular polygons. Irregular polygon. A polygon which is not having equal sides and angles. Irregular polygon means a polygon which is not having equal sides and angles. For example, let us draw a right angle triangle A, B, C. Here AB is not equal to BC and BC is not equal to AC. So we see that all sides are not equal and here at the B it will be right angle, that is 90 degree, and the angle near A may be differ and angle C will also differ. So we see that angles are not equal and sides are also not equal. So right angle triangle is an example of irregular polygon. Also rectangle. In the rectangle, opposite sides are having equal sides. A, B, C, D. Here AB is equal to DC and AD is equal to BC. So opposite sides are equal and the angles of each corner will be equal. Here angles are equal and opposite sides are equal. But all the sides are not equal. So that's why rectangle is also an irregular polygon. Therefore, an equilateral triangle and a rectangle are the examples of irregular polygons because it is not having equal sides and angles. Now, let us see the concept of angle sum property. In your previous classes, you have already learnt about angle sum property. Angle sum property of triangle. That means the sum of all angles of a triangle is equal to 180 degree. The sum of all the three angles of a triangle is 180 degree. So we know that the sum of all the three angles of a triangle is 180 degree. We got 180 degree from the formula, that is the sum of all the angles in a polygon with a number of sides is given as 180 degree into n minus 2. So, the sum of all the angles in a polygon with n number of sides is given as 180 into n minus 2. So, we have obtained the sum of all the three angles of a triangle is 180 degree by the formula 180 into n minus 2. For a triangle, 180 degree into, for a triangle we have three sides, so into 3 minus 2, that will be equal to 180 degree into 3 minus 2 is 1, so we got 180 degree. So we have obtained the angle sum property of triangle by this method. And angle sum property of quadrilateral. Angle sum property of quadrilateral is 360 degrees because from the formula 180 degree into n minus 2, we know that quadrilateral is a closed figure which is having 4 line segments, that means 4 sides. So 180 degree into n equal to 4 minus 2 equal to 180 degree into 4 minus 2 equal to 2. That equal to 180 into 2 is equal to 360 degree. Therefore, the sum of all the angles of a quadrilateral is 360 degree. The remaining topics will be covered in the next video. You are welcome to contact us on Telegram to clarify your doubts regarding these topics. Check out the link given in the description. Thank you for watching. Please do like, share, comment and subscribe to GeopByte.
GeopByte.